Integration by substitution. The method of integration is the method of integration related to the chain rule. If u is a function of x, then we can use this formula. The integral of f dx is equal to the integral of f divided by du dx du. Integrals which are computed by a change of variables is called u substitution. In this, we have to change the basic variable of an integrand, like x, to another variable, like u. This makes the integral easy to determine. Why u substitution? It's one of the simplest integration techniques. It can be used to make integration easier. It's used when an integral contains some function and its derivative. And without u substitution, there would be many integrals that we could not compute. So let's look below there. So our integral is the integral of f of x. This is f prime of x dx. So u is going to be f of x. Du is, we take the derivative, so the derivative of u is du. The derivative of f of x is f prime of x dx with respect to x. Right, so now notice that we have everything represented by u. Right, we took care of the f of x. We took care of the f prime of x dx. And now we can replace those with u du and have something we can integrate. So our integral is the integral of u du. Right, so that's now it's just a power rule. So we increase the exponent by 1, divide by the same thing, and now this is an indefinite integral. Right, so this is not, we're not finding an area under the curve. We're finding the function that has our integral as its derivative. Right? So we have to include the constant of integration, right? Because we don't know, there may have been a constant that was deleted, right? That's gone. Right? So we have u squared divided by 2 plus c. And now we just substitute back because the equation wasn't in terms of u's, it was in terms of f of x's. So we're going to replace the u with f of x, and then the integral becomes f squared of x divided by 2, or I should say f of x, all f of x squared divided by 2 plus c. Right? So now we can have a function raised to a power, rewrite it using substitution, and then be able to integrate it using the power rule and then substitute back. When to use u substitution? We have the function and its derivative together, whereby use of simpler methods like power rule and constant multiple rule, etc., is difficult to solve the integration. Our goal is to reduce the integral in such a way so that the power rule works by using substitution. When not to use substitution? If you fail to see such a pair of quantities, or you cannot rewrite to create such a pair, abandon this method. So a question to ask, do we have the function and its derivative together? Consider the integral of 3x squared times x cubed plus 5 to the 9th power dx. Right, now we have to make sure that we pick the right u so that it has its derivative. If we were to pick x cubed plus 5 to the 9th power to be u, that would be a problem because we don't have the derivative of x cubed plus 5 to the 9th power. We do, however, have the derivative of x cubed plus 5. Right? So if u is x cubed plus 5, then du is 3x squared dx. So that means we're going to, and how do we get the 3x squared dx? It's right there. And if we took the derivative, right, du, the derivative of u is du, the derivative of x cubed plus 5 is 3x squared. Right? And this is the derivative of u with respect to x, so we can move the x on the other side to just have du. All right, and that's how we get the parts. So now this becomes u, this becomes du, and the only thing that's left is the exponent. So now, using substitution, the integral becomes the integral of u to the 9th power du. Right, now that's easy to take the integral of, right? Look what we had before, right? There was no way to undo that until we use substitution and we make it easier, right? So now we take the integral, we increase the exponent by 1, we divide by the same thing. Don't forget the c. Now your equation wasn't in terms of u's, it was in terms of x's. So we need to replace that u with x cubed plus 5. So that makes the integral x cubed plus 5 to the 10th power divided by 10 plus c. And now we need to write this as an equation, right? F of x. Right? Now let's take the derivative and see if we get what was in the integral. So you can always check yourself by just taking the derivative. Do you get the same thing? All right, so if we take the integral, this would be f prime of x equals, the 10 would move in front, so we have 10 times x cubed plus 5 to the 9th power, because we've reduced the exponent by 1. There's already a 10 in the denominator. And then this is a chain rule, so it's the derivative of the outside times the derivative of the inside. So now we have to multiply that times the derivative of x cubed plus 5. And then if we take the derivative of the constant there, that's just going to be equal to 0. So that would be gone anyway. So now we would reduce. The 10s would cancel. And the derivative of x cubed plus 5, I'm going to put that in the front, would be 3x squared. So we have 3x squared times x cubed plus 5 to the 9th power. And see, now you can see, right? We did this correctly. All right, so on all of these, we're going to be using substitution. I'll check a lot of these just so you can see and you can know how to check it when you're solving it. So the steps for substitution: first, look for the function and its derivative. Choose the function to be u, take the derivative with respect to x, and isolate du. Replace the function derivative with u and du. So the function gets replaced with u, the derivative gets replaced by du. If du has something with it when you take the derivative, then just as long as it's a constant, just isolate du. I should say a constant multiple. Then we're going to integrate, we'll substitute back for u, and then to check yourself, take the derivative, you should get the integral again. Right? And this is all in your notes, and as is a lot of these examples. All right, so here's our first one. All right, so u should be the negative 5x. Right? So so we can go through all the different times you want to use substitution. All right, so one time is you substitute, I'm missing an I there, substitution, when x is in the variable. All right, so u is equal to negative 5x. Let's take the derivative. So this would be du dx equals the derivative of negative 5x would be negative 5. Right? Well, there's no negative 5 there, but that's okay. You can be short a constant. We just need to isolate. We need to move the dx to the other side by multiplying both sides by dx. And we're going to have to then divide both sides by negative 5. So here on this side, the dx cancels. You have du equals negative 5 dx. Then simply divide both sides by negative 5. So you're going to replace the dx with, and you can make it like this, negative 1/5 du. All right, so you need to replace that. So if you can have a constant, right? So if you have an extra constant, you just want to, that's okay. Just isolate the dx part. All right, so now we're going to keep the 2, right? Wasn't the problem, it's the negative 5x, right? Because there's a variable in the exponent. So we're going to replace the negative 5x with a u. So now we have 2 to the u. And now we need to multiply by negative 1/5 du. Anytime you have a constant, that can go in front of the integral, all right? So constants can be in front of the integrals. And I should say constant multipliers, excuse me. All right, so now we integrate. So this would be negative 1/5. Whose is this? All right, so now we're integrating something, a base to a power. All right, so normally when we take the integral, the derivative, right? So if I had 2 to the x, right, we were taking the derivative of that, right, we'd have 2 to the x, we'd still have the same thing, but because it's not e to the x, we have to multiply that by natural log of the base, right? So when we take the derivative, we multiply by natural log of the base. When we take the integral, we'll divide by natural log of the base, right? So this is going to be negative 1/5 2 to the u divided by natural log of 2 plus c. Right, and we'll write that as an equation. F of x, and we'll change, well, now I'll write it as an equation once I change the u's to x's, right? So we'll replace those u's with the x terms that u stands for, right? And then we'll simplify if possible. Right? So now this would be negative 2 to the negative 5x power divided by 5 ln 2 plus c. All right, so now if we want to check ourselves, let's take the derivative. So this would be f prime of x equals, right? So the derivative of 2 to the blop, or in this case, so we got a negative there. It'll be negative 2 to the blop, and the blop is negative 5x. And then times, now we have in the denominator, and that's okay, the 5 and the natural log 2 are part of just the coefficient in front. That still stays there. Right? But now we need to multiply by the natural log of 2, and then times the derivative of the negative 5x. And when we do that, well, the natural log of 2 will cancel out. Actually, let me take the derivative of the negative 5x, and then we'll start canceling everything out. So negative 2 to the negative 5x divided by 5 natural log of 2 times natural log of 2 times negative 5. All right, so now the 5 would cancel. The natural log of 2 would cancel. We've got a negative times a negative. That will be a positive. So f prime of x equals 2 to the negative 5x. And there we go. All right, so you can see we did this right because when we took the derivative, we got back to the integral. Right? And we know when we're taking an integral, right, we're just going from the derivative back to the original function. But here, there we go. There's our answer. Right? There's after we integrated. And that's the check. Sorry about that. All right, so now let's try this one. All right, so first of all, I'm going to split this integral up because I don't need substitution for both of them. All right, so I'm going to split this up into negative 5 over x plus dx, excuse me, plus the integral of e to the negative 2x dx. Now I can factor out that negative 5. You can factor out coefficients. So that would be negative 5 times 1 over x dx plus the integral of e to the negative 2x dx. Now we should know, you should know what the derivative, the integral, of 1 over x is. That one is pretty straightforward. It doesn't need substitution. The one that needs substitution is the e to the negative 2x. And again, we've got x as an exponent. So now let's make u equal to negative 2x. That makes du dx equal to negative 2. And actually, let's just write the dx on the other side. It'll just save us some trouble. Save us a step. All right, so the derivative of u will be, oops, I forgot to change back to yellow, du. All right, so, and this is negative 2 dx. Now you can write this, the dx over here and then move it over. Maybe I will do that just so that you understand where that comes from. Because normally if we just take the derivative of negative 2x, it's just negative 2, right? But we're taking this now, both sides, we're taking it with respect to x. The derivative of du with respect to x is du dx, right? Just like the derivative of y with respect to x is dy dx. All right, so now we can move the dx over, right? And we have to do one other thing. So du equals negative 2 dx. There's no negative 2 anywhere, right, other than the exponent, but there's no multiplied by negative 2. So we need to get rid of it because we don't have a negative 2 to replace du with. So we're going to divide both sides by negative 2. So that means negative 1/2 du is equal to dx. Right? So we'll replace that negative 2x with a u. We'll replace the dx on the second one with a negative 1/2 du. So now we have negative 5, 1 over x dx plus negative 1/2, and then it'd be the integral of e to the u du. All right, and so now we can do this and we'll be correct. All right, so the derivative of 1 over x is going to be natural log of x, and you use absolute value bars because it has to be positive. And now we have minus 1/2 e to the u because e is its own derivative. So long as it doesn't have, as long as its exponent is just a single variable, right? And then plus c. Now we need to substitute the u back, right? Because you put the u in, we got to put the x's back in. So now we'll just replace the u with the negative 2x. And now we'll rewrite that as an equation. Nope. I don't want f prime of x. Just want f of x. We'll check it, and then we'll have f prime of x. But f of x equals negative 5 natural log of x minus 1/2 e to the negative 2x plus c. All right, now let's check it by taking the derivative. So that would be f prime of x equals, right, so we'd have the negative 5 times the derivative of natural log of x, that's 1 over x. So negative 5 times 1 over x is negative 5 times x. And then minus 1/2 e to the negative 2x, because e is its own derivative. But then we have to multiply by the derivative of negative 2x, because it's not just an x. And then, of course, we know the derivative of the constant is 0. Right? So I won't write that each time. So f prime of x equals negative 5x minus, we'd have negative 1/2 that times negative 2x would make that a plus, just a plus, right? Oh, excuse me, we got one little error here. The derivative of, oh, I'm sorry, I didn't take the derivative yet. Well, I wrote it down, but never actually took the derivative. So why don't we take the derivative, and then we can simplify. All right, so still f prime of x equals negative 5 over x, and then minus 1/2 e to the negative 2x times the derivative of negative 2x is negative 2. So negative 1/2 times negative 2 is positive 1, so now we have f prime of x equals negative 5 over x plus e to the negative 2x. And we see we got right back to where we started from. All right, let's do another one. So I hope you're finding these easy. All right, so question to ask, do we have the function and its derivative together? All right, well, and it's okay if you're short a constant multiplier. So for instance, here, if u, and the u almost never includes the exponent. So here, let's look at another. So we need to use substitution when we have a x and an exponent. We also use substitution for an expression in a radical. Given you have the derivative of the expression in the radical. All right, so if u is 5x squared minus 7, and notice it, u will almost never include the exponent. The derivative of that would be, so du with respect to x, du dx would be 10x. All right, so now we want to isolate the du, so we'll multiply both sides by dx. All right, so then we have du equals 10x dx, but hey, I don't see the 10. So then multiply or divide both sides by 10. So 1/10 du equals dx. So we'll just replace the du, the dx with 1/10 du. Now we can do the substitution. So now we could put the 1/10 outside. 1/10 times the integral of, so now we're replacing this part here with u. Right? So that means u square root of u. And actually, we don't want square root of u, do we? No, we want to use power rule. So we technically want to change that square root to 1/2 power. So u to the 1/2 power. And then we're replacing the dx. We've already got the 1/10 part with the du. Right? So the 5x squared minus 7 becomes u. The dx becomes 1/10 du, and now we can integrate. So now this is just going to be 1/10 u to the 1/2. We're going to add 1, so 3/2 power, and then divide by the same thing, because we're undoing the power rule. So we'll divide by 3/2 and then plus c. All right, so now let's simplify that. That would be the same as 1/10. Dividing by 3/2 is the same as multiplying by 2/3. And then we can replace the u with the square root, just the 5x squared minus 7. If you want, I'll simplify first and then I'll replace it. All right, so that means that f of x is, so that will reduce, so the 2 and the 5 would reduce, that would be 1/15, or I could just write the 5x squared minus 7 to the 3/2 power divided by 15 plus c. And there we go. There is our equation. So now let's take the derivative to check. All right, so f prime of x equals, I guess I'll write the function up here and then. F of x equals 5x squared minus 7 to the 3/2 power divided by 15 plus c. All right, so then f prime of x equals, the exponent moves in front, so now we have 3/2, and that 15, that's 1/15, times 5x squared minus 7, reduce that by 1 to the 1/2 power, and then times the derivative of the 5x squared minus 7. We know the derivative of the constant is just 0. So that gives us f prime of x equals, all right, so now we can reduce this a little bit. The 3 and the 15 cancel out. So now we have 1 times 10, 5x, 1 times 10, 1/10. The 1/10 and the 10 cancel, and that's going to give us, and we could simplify that 1/2 exponent, but that would give us x times the square root of 5x squared minus 7. There you go. So you see, all right, this is our check, and our check worked out. When we took the derivative, we got right back to what's under the integral sign. Let's do another one. All right, so here's our next one. All right, so now u is going to be the natural log of x. You got something to a power. All right, so now our next reason, use substitution. When you have a function raised to a power. Now, not just an x, because the derivative of x would be 1. But no, when we have a whole function raised to a power, we want to use substitution. All right, so we're going to let u equal the natural log of x. Let's rewrite this first of all. All right, so this would be the integral of, you know what, we'll just leave it the way it is right now. Then we'll do the substitution, and then we'll rewrite it so we can take the derivative. All right, so u is natural log of x. If we took the derivative, right, so du with respect to x, the derivative of natural log of x is 1 over x, right? And then we would move the dx to the other side, right? So we have du equals 1x dx. So this is really 1 over x du is, well, they moved it over, but the du is the 1x dx. I don't like the way this was written. I didn't type that part in. Sometimes I need it just so I can have the function all written all pretty, and you don't have to always look at my horrible handwriting. But this right here is the du, because 1 over x is the derivative, natural log. And then this part here is the u, and the only thing we're leaving is the exponent. So now this would be the integral of du. Okay, so now du in the numerator there is replacing the dx and the x that's in the denominator. Right? And then the u is replacing the natural log of x. So we have du divided by u to the third power. All right, let's rewrite that. So that would be the integral of u to the negative 3 power du. I realized it would probably be just easier to deal with it after we substituted in the u's, and then we could deal with changing that exponent to a negative exponent so it wasn't in the denominator. And now we can just use the power rule. So we increase the exponent by 1 and divide by the same thing. Right? So this would be u to the negative 2 power divided by negative 2 plus c. And now we'll substitute back. So now we have f of x equals, right? So we have, we'll just substitute and then we'll simplify that negative exponent. Natural log of x to the negative 2 power divided by negative 2 plus c, right? And then let's just simplify the negative exponent. F of x equals 1 over, let's make it negative 1. Negative 1 over 2 times natural log, whoops, when I did the substituting back, my natural log of x became Lx. Oh, that's not good. Let's fix that. There we go. All right, so we have so f of x equals negative 1 divided by 2 natural log of x. That's supposed to be an absolute value. And that is all to the negative 2 power. There we go. All right? And we can do a check, right? So, oh, and then don't forget our plus c. Come on, plus c. There it goes. All right, so this is our final answer. All right, let's take the derivative so that we can check our work. So we have f prime of x equals, or excuse me, let's write the equation first. F of x equals, and we'll keep that negative exponent. Oops, the negative exponent which got lost over here. All right, so f of x equals negative 1/2 times natural log absolute value of x, as we know it has to be positive, raised to the negative 2 power. Of course, you take the derivative of the c, it's 0. All right, so then we have f prime of x equals negative 1/2 times, the negative 2 moves in front, natural log of x, and then the exponent decreases by 1, so that would be to the negative 3 power, and then times the derivative for the natural log of x. I'll just squeeze it in without the absolute value so I can get it in there. All right, so then that would be f prime of x equals the negative 1/2, negative 2, that just becomes a 1. Right, so if we wanted to simplify the negative exponent, that would move to the denominator. So in the denominator, we would have the natural log of x raised to the 3rd power. And then the derivative of natural log of x is 1 over x. And you see, we got back to the original equation. All right, so you can see, you can always check your work. If you're not sure, hey, did I do that right? Just take the derivative. Do you get back to the same thing? If yes, then you did it right. All right, so now let's try this one. All right, so our u, this is another one of those. And do we have x, a variable and an exponent, right? So we have the 3t in the exponent there. So u is going to be, and now u is not going to just be the 3t part. No, because that wouldn't work, right? That would not work with what we've got. The u this time is e to the 3t. Right? Because we want something whose derivative is going to be e to the 3t. Right? And so we've got 2 e's here. Right? So that means that the whole expression. Right? So here's another one. Use substitution. This is slightly different than just an exponent. And again, this would technically be a variable raised to a power, right? So this was a variable in the denominator. That's like being raised to negative 1 power. So use substitution if a variable expression is in the denominator and its derivative is in the numerator. All right, so u is e to the 3t plus 2. The derivative du with respect to x. The derivative of e to the 3t would be e to the 3t times the derivative of 3t. The derivative of the 2 is 0. So that makes, we'll move the dx to the other side. We'll take the derivative of 3. So that means du is e to the 3t times 3. We don't have a 3, so we're going to divide both sides by 3. So 1/3 du equals e to the 3t. All right, so we're going to replace this with the u. we're going to replace this with 1/3 du. Right? And then we got everything taken care of. Right? So we have the integral, and we can put the 1/3 in front. 1/3, and then we have, so we have 1 over, because that's in the denominator, we have 1 over u du. Right? And everybody's been taken care of. We've replaced the e to the 3t dt with a 1/3 du. We replaced the e to the 3t plus 2 in the denominator with a u. And now let's integrate. This is an easy one. 1/3, whose derivative is 1 over something? It's going to be, so 1 over just a little something in there is going to be natural log. So this is natural log of u. And we'll put that in parentheses. And then plus c. All right, so now we'll just substitute back. Right, so f of t this time is 1/3 natural log of e to the 3t plus 2. Now I can drop the absolute value bars and just use parentheses because this is always positive. So e to the 3t plus 2 is always greater than 0. So it's fine. It doesn't matter if I put parentheses, absolute value bars or parentheses in there. And there we go. All right? And if you want, we can check it. All right, so I won't write it again. F prime of t equals 1/3. Right, so the derivative of natural log blop would be 1 over the blop, e to the 3t plus 2, times the derivative of the blop. All right, so that's going to give us 1/3 times 1 over e to the 3t plus the 2. And then the derivative of e to the 3t plus 2 is e to the 3t times the derivative of 3t part, so times 3. All right, the 1/3 and the 3 cancel. So then f prime of t equals e to the 3t over e to the 3t plus 2. And there we go. You can see it matches. And this was what we get after we integrated. And so to me, it's like a little puzzle. Just kind of undoing everything using substitution. All right, so now let's try this one. We need to stop pretty soon. Let's see how many there are before my place that I was going to stop anyway. Oh, there's a few. So I'll tell you what, I will stop right now, and actually, you know what? Let's just do this last one, and then I'll stop. All right, so u, because this is an easy one, u, we got a variable expression and an exponent. U is the x squared. The derivative of u with respect to x is 2x. We got everything we need except we need to move the dx over to the other side. So du equals 2x dx. So the e stays, but that's replaced with a u, and all of this is replaced with du. All right, so then we have the integral of e to the u du. Couldn't be easier. It's e to the u plus c. All right, and now all we got to do is replace the u. So f of x equals e to the x squared plus c. And now we can test that by taking the derivative. So here's our check. F prime of x equals e to the x squared times the derivative of x squared, and then of course plus 0 for the constant. So f prime of x equals, the derivative of x squared is 2x. So 2x e to the x squared. And that one checks out, and that's the integral. And then I'm going to end this video, and we'll do some more substitution. We'll crank it up a bit in the next video. All right, bye for now.